Hello viewers, I'm Kausalya. Today we are going to discuss about network theorems. So here comes the first problem. Compute the current through 23 ohm resistor of the figure below by using superposition theorem. So here what is meant by superposition theorem is the superposition theorem can be used for circuits which have more than one source. Right. For example, the circuit may have two sources or three sources. So in this case, the basic procedure here is first you have to consider only one source at a time and we have to calculate the thing which is asked in the problem. For example, here you see we are having two sources, right? One is a voltage source and another is a current source. So here the voltage source is 200 volt and the current source is 20 amps. So what is the problem about? We have to find the current through 23 ohm resistor. So here in this case, we have to consider only one source at a time. For example, if you consider 200 volt, you have to leave this 20 amps and you have to calculate the current that flows through this 23 amps by this 200 volt source. And the second thing is, if you consider 20 amps, right, when you consider this current source, then you have to leave this 200 volt source. Okay, you have to remove this 200 volt source and you have to calculate the current through this 23 ohm resistor, right? And finally, we will sum those values. So we will start the problem. So the first thing is we are considering only the 200 volt source. So when you consider 200 volt source, what happens? We will remove this 20 amp source. So you see the same diagram I have redrawn here. Here we are considering only this 200 volt source. This is clear, right? So this 20 amp source is removed. So here when you remove this source, that is here we don't have anything. So what happens, you see, this 4 ohm and this 23 ohm resistor are in series, right? So just when you add, just combine these two values. Okay, just we have to add. So when you add 4 plus 23, that gives the answer of 27 ohms. So these two branches are drawn as such and these two resistors are combined as 27 ohms here, right? Now again we have to simplify the circuit. So the thing is, again I had redrawn the circuit here. So you see this 200 volt with 47 ohms and this 27 ohm and this 27 ohms are drawn like this. That is, this diagram and this diagram are the same because all these three branches are parallel to each other, right? So this diagram that is drawing like this and drawing like this doesn't make any difference, right? It will simplify our calculation further. And the next thing is, you see, these two resistors are in parallel. So we are combining these two resistors into a single resistor. So here what is the formula? That is R1 into R2 divided by R1 plus R2. This is the formula, right? So by using this formula, the value is calculated as 13.5 ohms, right? Now, this circuit, you see, this is further simplified, right? We are having these two resistors in series and we are having a voltage source. So we can easily calculate the current that flows through this circuit. So here 47 plus 13.5 gives 60.5 ohms. So here I had made the calculation how we get 13.5, right? And next we are calculating the total current here. So the total current is given by V by R. We know the voltage source, we know the resistance, therefore the total current is 3.306 amps, right? But what is asked in the question? We have to calculate the current that flows through this 23 amps resistor, right? Again we have to look back at the circuit. So what we need actually is the current that flows through this 23 ohm resistor, right? So to calculate the current that flow through this 23 ohm resistor, you see, the current flowing through this 23 ohm resistor flows through this 4 ohm resistor also because they are connected in series. So in other words, the current that flows through 27 ohm resistor is similar to the current that flows through this 23 ohm resistor. Can you get? these two are in series, right? We have combined it as 27. So the current flowing through this path is same as the current flowing through this path, right? So as I already said, this circuit and this circuit are same, right? They don't make any difference. So you see, now we are going to calculate the current that flows through this 27 ohm resistor by using the current division formula. So what is the formula here? Total current into opposite resistance. What is the resistance opposite to this 27? It is again 27. So 3.306 into 27 divided by total resistance. So what is the total resistance? Here 27 plus 27, right? So here when you substitute the values, finally the current through this 23 ohm resistor is calculated as 1.653 amps here, right? Now we are moving to the second step. Here we are considering only the current source, right? So when you consider the current source, our circuit diagram is like this, right? Again we are going to simplify the circuit diagram. So from the circuit diagram it is clear, right? These two are in parallel. So just simplify these two into a single resistor. So 27 into 47 divided by 27 plus 47. So that gives the answer as 17.14 ohms, right? So I am redrawing the circuit here, right? These two are combined into 17.14 ohm, and here the 4 ohm resistor, here this 20 amps current source and this 23 ohm. Again you see these two things are in series. So we can directly add these two values. So that gives the answer as 21.14 amps, right? Again I am redrawing the circuit, right, to make our calculation simpler. That is, these three are parallel, right? So I am bringing this 20 amps to one side and the remaining two resistors here. Again by using the current division rule, because we need to calculate the current that flows through this 23 ohm resistor, right? So here the total value of current is 20 amps because here we directly have a current source. So 20 amps into opposite resistance. What is the resistance that is opposite to this 23 ohm? It is 21.14 ohm. So 20 into 21.14, right, divided by total resistance. You have to add these two. So that is the thing what I have written here, right? So this gives the answer of 9.57 amps. So I am writing it as 9.6 amps, right? So in both the cases, you see, the current flows through this resistor in this way. So here we can add both the values of current. So when you add, you see 1.653 plus 9.6, that gives the answer as 11.253 amps. Therefore, the total current that flows through the 23 ohm resistor is 11.253 amps, right? So here comes the end of this problem. We will move with the next one. The problem is find the load current IL, load voltage VL and the load power in the circuit by using the principle of superposition. So again here you see we are having two voltage sources. So in this diagram, this RA and RB, okay, they represent the internal resistance of the source, right? That is the resistance which is present within the source. So anyway, while calculating the value of resistance, we should consider these two values also, okay? You should not neglect this. So again, while proceeding, the first step is we are considering our 225 volt source, right? So when you consider 225 volt source, you have to remove this 220 volt source, but anyways, you have to consider this 1 ohm resistance, right? You see here, I had redrawn the circuit, right? So the next thing is, as usual, we have to simplify, right? And again, here I forgot to say, you see, this is your IL, okay? The current flowing through the 6 ohm resistor is IL, and the voltage drop across the 6 ohm resistor is known as the load voltage, right? So here we are going to calculate the total resistance now. So when you calculate total resistance, you see what happens. Again, this 11/3 and this 1 ohm are in series. So we have to simply add these two values. So when you add, the net answer is 4.67 ohms, right? So again, when you redraw the circuit, you see these two resistors are replaced with a single value of resistance here, right? Then again the next thing is these two resistors are in parallel, right? So how to combine parallel resistors? R1 into R2 divided by R1 plus R2. So that gives the answer as 2.626 ohms, right? So again, when you redraw the circuit, you see our circuit gets much more simplified. So what is the total resistance here? When you add these two, that is these three values, here we are having a 0.9 also. So that gives the total resistance of 5.626. Therefore, we can easily calculate the current that flows through the circuit. So I is nothing but V by R. We know the value of V, we know the value of R. So just substitute, and here the final answer is calculated as 40 amps here, right? So now we are going to calculate the current through 6 ohm resistor. So here again looking back, you see we are taking this circuit, right? We have combined the remaining those two resistors and we have written it as 4.67 and this 6 ohm as such, here 2.1 and here 0.9. So the total current flowing through the circuit is 40 amps, right? So this 40 amps gets divided into 2 in these two resistors. So again using the current division formula, total current into opposite resistance. The resistance which is opposite to 6 ohm is 4.67. So 40 into 4.67 divided by the total resistance. So 6 plus 4.67. So that gives the answer as 17.5 amps. Right. So by using a 225 voltage source, we have calculated the current that flows through 6 ohm resistor. Now next, we are proceeding with the 220 volt source. So when you look at the 220 volt source, you see again our circuit gets modified like this. Here the internal resistance of this source is considered, right? So again we have to simplify. So how to simplify? Again these two resistors are in series. So combine them, okay? Here we are getting the value as 3. And again these two are in parallel. Therefore, when you combine here the answer becomes 2 ohms. And finally here we are having 2 ohms, 11 by 3 and a 1 ohm. So now again calculate the total resistance and find the total current. Therefore the total resistance, you see, it gives 6.67 ohms and the total current is V by R. So here the voltage is 220 volt and the resistance is 6.67. So that gives the answer as 32.98, that is 33 amps here, right? Now again we are moving back to the previous circuit since we have calculated the total current, right? So we are considering this circuit, right? Because you see we need to calculate the current that flows through the 6 ohm resistor. So anyway we need the 6 ohm resistor and this side of the 6 ohm resistor is simplified, right? So it will be easy when we take this circuit to calculate the current that flows through this part. So again by using the current division rule, right? The total current is 33 into opposite resistance. Resistance which is opposite to this 6 ohm is 3 ohm. So divided by total resistance is 3 plus 6 here. So when you solve, finally the answer is 11 amps, right? So in the previous case the answer is, in the previous part the answer is 17.5 amps. So here the result, the load current IL is 17.5 plus 11, so that gives 28.5 amps. And the next one is load voltage. Load voltage, what is the formula to calculate voltage? It is nothing but IA into R. So IL, we know the value of IL and the load resistance is 6 ohms. So just substitute, here the answer is 171 volts. And the next load power, so power is given by I square R. We know the value of I and the value of R also, right? So just substitute in this formula and finally the answer is 4873.5 watts, right? So here comes the end of this video. If you have any doubt related to this, let me know in the comment section. Thank you.